All right, welcome back everybody. In this video we're going to discuss information related to section 810 of AP Calculus volume with the disk method revolving around other axes. A little bit of text out front here. It talks about, we're looking at revolving regions around non-axes. Specifically, we're going to focus on other horizontal or vertical lines. And I mention here in parentheses, it's possible for us to revolve regions around other lines other than horizontal or vertical ones. But it's such a mess algebraically that nobody really even talks about doing it. But realistically, we could do that, and it would just kind of require some kind of transformation in the curves that we're dealing with. Not something that we really want to talk about in this course. Let's see, second paragraph here. Last lesson, when we talked about the disk method, we treated our function, the function that formed the boundary of the region, as the radius of the solid. That worked great when we were talking about an axis. It wasn't quite the whole story, and if you were really paying attention in the last video, you might have noticed that I talked about the radius being the distance from that boundary to the axis of rotation, and that's in fact how we're going to approach this now that we're revolving around other axes other than the x-axis and the y-axis. We're going to treat that radius as the distance from the boundary to the axis of rotation. And we'll talk about that in our examples today. And then one last thing to talk about. We talked about how, in the last lesson, we talked about how if we were revolving around the x-axis, everything was going to be in terms of x. And if we were revolving around the y-axis, then everything was in terms of y. We can extend that when we're revolving things around non-axes. Basically, if we revolve around the x-axis or any line that's parallel to the x-axis, so any line of the form y equals some number, everything in our integral should be in terms of x when we revolve around the y-axis, or a line that's parallel to the y-axis, everything's going to be in terms of y. And so that's really the only new thought that we're those are really the only new thoughts that we're bringing in today. Let's look at a couple examples. Very short lesson here. Example 1. Find the volume of the solid generated by revolving the region bounded by the curves y equals negative x squared plus 4 and y equals 2 around the line y equals 2. So this is the line that we're revolving the region around, and it forms an entire boundary of the region. So we're going to use the disk method. Now, extending to our conversation for today, the radius of rotation is going to be the distance from the parabola down to this horizontal line. This is a horizontal line, a line that's parallel to the x-axis, which indicates to me that everything in my integral should be in terms of x, which is nice because all of my equations are in terms of x to begin with. So let's go ahead and we'll start setting this up. We're going to set up an integral, and the radius is going to be the distance from the parabola down to this line. And the way I find distances in one dimension is I take the bigger value minus the smaller value. The bigger value on this line segment is on the parabola, so that's going to come first. And so the distance from that curve to the line y equals 2 is going to be the equation of that curve minus 2. So that's our radius, which we're going to square. Don't forget your pi out in front as we rotate here. And now I just need the limits of integration. I'm going to go ahead and calculate these. I could do it by hand, but I don't really need to. I'm not here to impress you with my skills at taking integrals by hand or anything. And since I have a calculator handy, I'm going to use it to help me in this process. So y equals negative x squared plus 4, even though I already know what the values are in my head. As I was talking there, my brain kind of found them for me. I want to go to a standard window. So there are my curves, and we're going to find the intersections of those. And the first one is at negative 1.414, which this is actually negative square root of 2. And the other one on the opposite side, this is symmetric about the y-axis, so that's going to be positive square root of 2. And so I can go ahead and find my integral. So we're going to have pi times the integral of the quantity negative x squared. And when you type this into your calculator, you can feel free to simplify that. Take that whole quantity squared with respect to x from negative square root of 2 to positive square root of 2. And that gets us the volume of our solid. 18.956 is going to be the volume of the solid created by revolving this region around the line y equals 2. Okay, example 2. Find the volume of the solid generated by revolving the region bounded by y equals natural log of 2x, that's this curve, x equals 2e, that's this line right here, and the x-axis around the line x equals 2e. So here's our axis of rotation. It forms an entire boundary of the region that we're revolving. So we're going to use the disk method. This line is vertical. It's perpendicular, or parallel to the y-axis. Therefore, I want everything in my integral to be in terms of y here. Okay, so we're going to set this up. We've got pi times the integral. Now I want everything in terms of y. So my radius is the distance from this line over to this curve. This curve is y equals natural log of 2x. If we solve this for x, it's going to be, let's see, we take e to both sides, so e to the y, and then divide both sides by 2. So 1/2 e to the y is equal to x. That's that curve as a function x equals some function of y. And this is the line x equals 2e. So the distance from here to here, this point is on the line x equals 2e, so that's going to be 2e minus, and this point is on the curve x equals 1/2 e to the y. So that's going to be my radius for this solid. So I square that with respect to y. And now I just need my limits of integration, which are going to be the y values at either end of this region. The y value here is 0, so that's not too bad. The y value up at the other end is where x equals 2e intersects x equals 1/2 e to the y. And so I could solve this by hand. We've got 2e is equal to 1/2. 2e is equal to 1/2 e to the y. So multiply both sides by 2, so 4e is equal to e to the y. Take the natural log of both sides. I get y equals the natural log of 4e. Do I want to simplify that? I don't really feel like I need to. This is going to be the natural log of 4e. And now I can go ahead and calculate the value of my volume. And I've got pi times the integral of 2e to the first minus 1/2 e to the y with respect to y from 0 to natural log of 4e. I think I've got enough parentheses there. And there is the volume of our solid. We're going to say 25.248. 25.247 also acceptable. All right, so I mean really that's it. That's all we really need to consider in these problems. You want to go ahead and do some practice and get yourself really solid with the disk method. In the next lesson, in section 8.11, we're going to introduce you to the washer method and start finding some volumes of solids generated that require the washer method to find their volumes. So, preview of coming attractions. Have a great day, everybody, and we'll see you next time. Bye-bye.